All right, so the next thing we're going to look at is something called the unit circle, which is a tool that you can use to find exact trig ratios of different angles. Okay, so when we talk about the unit circle, unit is just like a fancy math word for the number one. Okay, so all that the unit circle is it's a circle, all right, and it's set up so that the radius of the circle is 1, right? That's where the unit part comes from. Come on, marker, there we go. All right, so the radius of the circle is 1, and the center of the circle is at the point 0, 0 on the coordinate plane. Okay, so you can kind of see here I've drawn a circle. Here's kind of like your x and y axis. All right, the radius of the circle is 1. So that dashed line there, that's 1. Okay, this equation right here, that's just the equation for the circle. So if you're familiar with equations of circles at all, then you should be like, oh yeah, that's a circle. All right, if you're not familiar with equations of circles, it basically just says this guy right here is the square of whatever the radius is. So since 1 squared is 1, it's a 1. If the radius of the circle was 2, 2 squared would be 4, so you'd see a 4 here. Okay, and this just tells you, since no changes have happened to the x or y, nothing's been added or subtracted, that just tells you the middle of your circle is at 0, 0. You don't really need to know that. That's just a little side bit. Okay, so this is kind of what your unit circle looks like. All right, and here's why the unit circle is super helpful when it comes to trigonometry. Okay, so we've got a point here that's on the unit circle, and we'll just say that the coordinates of that point are x, y. Okay, so what we can do is we can say, well, if here's my radius of my circle, right? If I make that triangle with the closer side of the x-axis, and then I've got my reference angle here, remember doing this? Okay, well, the cool thing is that because this is 1, if you think about at that point, the coordinates that are x, y, that means that I went over x and up y to get there, right? So this side of the triangle would be x long, and this side would be y long, right? However far x is and however tall y is. So the cool thing is then, if your hypotenuse is just 1, when I go to find my sine and my cosine, my sine would be opposite over hypotenuse. Well, y over 1 is just y, right? So the cool thing is that when I use this point xy, the y coordinate, that is going to be what my sine of my angle is. Okay, and then the x coordinate, similarly, when I go to find cosine, cosine is adjacent over hypotenuse, but if the hypotenuse is 1, it's not going to change anything. So the x coordinate is going to give me the cosine of whatever the angle is. So as long as you know the coordinates of a point on the unit circle, the first coordinate will be your cosine of your angle, and the second coordinate will be the sine of your angle. Okay, and that's why we bother with this unit circle thing. It's just a really cool thing. All right, do kind of make a note to yourself here, right? Cosine and then sine, they go in alphabetical order, but not really in the order. Like usually we say sine, cosine, tangent for SOHCAHTOA, right? So just be aware they don't go in that order. They go alphabetically. Okay. All right, so how are we going to use that? So we're going to use this to find some exact values of different angles. So to look at this guy, I'm going to start by just drawing a picture. So the sine of a 225-degree angle, first I want to figure out where does 225 go. So here's 0, 90, 180, 270 is down here, right? So 225 is going to be somewhere over here. And what we want to figure out, okay, is when I make my reference triangle, I need to know what is that reference angle. Okay, so I know this is 180 degrees, and I need to get up to 225. So I need to figure out, well, how much more is it from 180 to 225 to figure out how big that angle is. So 225 minus 180, 45. Okay, so if this going straight over, that's 180 degrees. So from here to here is 180. And I need to get up to 225. That means that this has to be a 45-degree angle. Okay, so once we know that, right, as long as I'm setting this up so that I'm saying that this point right here is on my unit circle, then I can kind of cheat. So theoretically, we have been looking at some special right triangles, the 30, 60, 90, and the 45, 45, 90. Okay, so theoretically, we've done this before. I hope that we have. So you should have been doing this kind of in class and with your homework. All right, so what I'm going to kind of do is I'm going to look at this, and we've established that as long as the hypotenuse is 1, that in a 45, 45, 90-degree triangle, both of these sides are going to be root 2 over 2. So what I'm going to kind of do is say, okay, well, if I sort of orient this so that it faces the same way, as this triangle that I drew here. Okay, well then that tells me the coordinates of that point. So this tells me that the coordinates of that point, I went this way, root 2 over 2. It's upside down, but root 2 over 2. And since I'm going left, that's negative, right? Make sure you watch your signs. So that's going to be negative root 2 over 2. And then my downward coordinate, upside down again, but is also going to be root 2 over 2. Okay, so root 2 over 2, I'm going down, so negative root 2 over 2. So there's the coordinates of that point. All right, well, now that we know the coordinates of that point, that's going to make this pretty easy for me. If I want to find the sine, okay, well, I just have to remember that this guy is the cosine and this guy is the sine. And that's it. So what's the sine of 225 degrees? Well, the sine of 225 degrees is going to be negative root 2 over 2. Let's check. If I type in the sine of 225, it's negative. This is going to give it to me as a decimal, so let's just check what root 2 over 2 is. So the square root of 2 divided by 2, same number. Okay, so we got the correct trig ratio. All right, and that's how we're going to use the unit circle. So let's look at this next one. Now we're going to find all 6 trig ratios for this guy. So again, I'm going to start by setting up a picture. So 120 degrees. Okay, well, here's 0, here's 90, here's 180. So 120 is going to be between 90 and 180. It's closer to 90, right? So that's up here somewhere. All right, so if this from here to here is 90, and we need to get up to 120, that means that this has to be 30 degrees, right? Okay, that's great, but remember that's not my reference triangle. So my actual reference triangle, we always go to the x-axis. So if this is 30 degrees, that makes this 60 degrees. Okay, so another way you could have thought about it is you could have said, well, if this is 180 degrees, but I only went to 120, how much farther would I have to go? How much farther would I go to go from 120 to 180? 60 degrees. Okay, great. So then I can use my reference triangle. So here it is. All right, and I can use that to figure out the coordinates of this point, again, assuming that I'm putting this on my unit circle. Okay, so the coordinates of that point, which I'm going to kind of write over here because I can't fit it in. All right, so the coordinates of that point is I went over 1/2 in the negative direction, so that's going to be negative 1/2. And then I went up root 3 over 2. Since I'm going up, it's positive. So root 3 over 2. There's the coordinates of my point. All right, excellent. So once I know that, now finding the rest of my trig ratios is going to be fairly easy. So the sine of 120 degrees, remember it's cosine and then sine. So that'll be root 3 over 2. The cosine of 120 is negative 1/2. Okay. All right, now I'm going to skip tangent for just a second. We'll come back to that one. So that gives me then cosecant of 120, which is just going to be the flip of this. You can leave it as 2 over root 3, right? Or you can rationalize it to 2 root 3 over 3. I would take either. And then the secant of 120 is this guy flipped, so that'll be negative 2 over 1 or negative 2. So the only one that's a little bit tricky is tangent. Tangent and cotangent can be a little bit tricky because how you're going to find tangent, all right, the trick to knowing tangent from your unit circle is that you need to know that tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. Okay, that is a piece of information that you're going to need to know. So that the tangent is equal to the sine divided by the cosine. So when I want to find my tangent of 120, okay, I'm going to have to do this divided by that. Okay, so let's see. I need a little bit of extra work. So let's come over here. We'll come down here and do a little bit of work. Okay, so I'm doing root 3 over 2, that's the sine, divided by negative 1/2, that's the cosine. So remember when you divide fractions, you change it to multiplication and you flip the second one, right? Oops. All right, and then we'll multiply straight across. This is going to give me negative 2 root 3 over 2. And then the 2's will cancel out. So that'll be negative root 3. So I took the sine, divided it by the cosine. To divide fractions, you change to multiplication and flip the second one. So my tangent is going to be negative root 3. And my cotangent is going to be the flip of that. So it'll be negative 1 over root 3. You could also rationalize that to negative root 3 over 3. I would take either. Okay, so there's my 6 trig ratios. All right, and then one last one. So cosine of 90. So the weird thing about this one is that 90 degrees is on your axes, right? So 90 degrees would be up here. So when I draw my angle, it's kind of like, well, okay, how do I draw my reference triangle for that? And it's kind of weird. But we don't need a reference triangle for this one. The thing that I'm using my reference triangle for is to help me figure out how long each side is, right? What are the coordinates of my point? I already know the coordinates at this point, right? The unit circle by definition tells me that this length here is 1. And if I'm on an axis, you should be able to pull out what the coordinates of that point is, right? To go to this point from the origin, I went left and right 0. So my first coordinate 0. And then I went up 1, right? That's the length of the radius of the unit circle. So the coordinates of that point are 0, 1. So the sine of 90 degrees is 0. And the cosine that they asked me for, I did it backwards. I'm sorry. I just lied to you, right? Because you got to remember they're alphabetical. They don't go in the order. I always screw that up. So watch out that you don't. That's not sine, that's cosine. Cosine of 90 degrees is 0. The sine of 90 degrees would be 1. Okay? So anytime you've got one of these 4 points here, just think to yourself what the coordinates of that point are. This point right here, that's negative 1, 0. So the cosine, negative 1, the sine, 0. This guy right here, that's 0, negative 1. So the cosine, 0, the sine, negative 1. That's 1, 0, cosine 1, sine 0. Okay, so just think for those 4 coordinal points for a second. Which one is it? What are the coordinates of that point? It's going to be a 0 and a 1 or a negative 1 in some direction. You just have to figure out what they are.